Hey everyone, welcome back to Set For You. In today's video, I'll be working through the iGCSE Higher Maths November 2025 Paper 2 exam. So grab a pen, some paper and a calculator and let's get started. In the first question, we are told that the point P has coordinates 3, 4, the point Q has coordinates 9, 16, M is the midpoint of the line PQ. Find the coordinates of M. So in order to determine the coordinates of the midpoint, we need to take the average of the x coordinates respectfully and the average of the y coordinates respectfully. So the average of the x coordinates is 3 plus 9 divided by 2, and the same can be said about the y coordinates, which is 4 plus 16 divided by 2. And so the final answer is 6, 10. In the second question, we are told to solve the simultaneous equations. So the first thing I'm going to do is label the first equation as equation 1 and the second equation as equation 2. And given as we have y in both equations, I'm going to add equation 1 and equation 2. And that gives me 8x equals 20. And when I divide both sides by 8, I have x equals 20 over 8, and that simplifies to 2.5. So my value for x is 2.5. And in order to determine the value for y, I can substitute this value of x into either equation 1 or equation 2. So when I substitute x into equation 2, I have 3 times 2.5 minus y, and that equals 9. So 7.5 minus y equals 9. Therefore, y equals 7.5 minus 9, and that is simply minus 1.5. So my value for y is minus 1.5, and these are my final values. In question 3, we are told that a box contains only 9 red bricks, 43 blue bricks, and some yellow bricks. 7/20ths of the bricks are yellow bricks. Each brick weighs 35 grams. Work out the total weight of the yellow bricks. So we know that the total number of bricks in the box, which I'll represent as T, simply equals 9 plus 43 plus X, which represents the yellow bricks. And so if we simplify this equation, we have 52 plus X. And given as 7/20ths of the bricks are yellow bricks, we can simply state that 7 over 20 times T equals X. And so I can substitute this equation for X into the equation for T. So T equals 52 plus 7 over 20 multiplied by T. And if I subtract 7 over 20T from both sides, I have 13 over 20T. And that equals 52. Therefore, T simply equals 52 divided by 13 over 20, and that equals 80. So this means that there are a total of 80 bricks in the box. Therefore, the number of yellow bricks can simply be obtained by multiplying 7 over 20 by 80, and that is 28. And given as each brick weighs 35 grams, the total weight of the yellow bricks can be obtained by multiplying 28 by 35, and that gives us a value of 980. So the final answer is 980. In question 4, we are given 3 similar quadrilaterals. Work out the length of JK. So given as these quadrilaterals are similar, the first thing we need to obtain is a scale factor. And the scale factor can be obtained by dividing the length AB by the length EF. So 28 divided by 7 equals 4, and that represents our scale factor. And in order to determine the length JK, we firstly need to determine the length FG. So the length FG can be determined by dividing the length BC, which is 60 centimeters, by 4, and that gives us 15 centimeters. And in order to determine the length JK, we need to divide the length GH by the length KL. So our second scale factor can be determined by dividing 18 by 6, and that gives us 3. Therefore, the length JK can simply be determined by dividing the length FG by 3. And that gives us 15 divided by 3, which is 5. So the final answer is 5 centimeters. In question 5, we are told that Otis sells ice creams. On Friday, Otis sells 75 ice creams. On Saturday, Otis sells 87 ice creams. Work out the percentage increase in the number of ice creams Otis sells from Friday to Saturday. So using this equation for the percentage increase, we can simply state that 87 minus 75 divided by 75 multiplied by 100 will represent the percentage increase in the number of ice creams Otis sells from Friday to Saturday. And when you put that into your calculator, you get a value of 16%. In the second part of this question, we are told that Claudia buys an ice cream machine for 960 Swiss francs. The value of the ice cream machine depreciates by 20% each year. Work out the value of the ice cream machine at the end of 3 years. So given as the value of the ice cream machine depreciates by 20% each year, we can subtract 20% from 100%, and that gives us a value of 80%, which we can also write as 0.8. And if we wanted to determine the value of the ice cream machine after the first year, we would multiply 960 by 0.8. However, given as we want to work out the value of the ice cream machine at the end of 3 years, we need to raise 0.8 to the power of 3. And that gives us a value of 491.52 Swiss francs. And that is your final answer. In question 6, we are told that a large circle with center O contains 3 identical small circles. Each circle touches 2 other circles. A, O, and B are the centers of the small circles. AOB is a straight line. The circumference of the large circle is 160 centimeters. Work out the area of one small circle. So the first thing we need to identify is that the circumference of a circle can be determined by multiplying pi and the diameter, and this is also the same as 2 pi times your radius. So we can state that 2 pi multiplied by the radius of the large circle equals 160 centimeters. So the radius of the large circle can be determined by dividing 160 by 2 pi, and that simplifies to 80 over pi centimeters. And if we take a closer look at our diagram, we can see that 3 lots of the radius of the small circle is equivalent to the radius of the large circle. So the radius of the small circle can simply be obtained by dividing the radius of the large circle by 3, and that gives us 80 over 3 pi centimeters. And given as the area of a circle is pi r squared, the area of one small circle can simply be obtained by multiplying pi by the radius squared, so 80 over 3 pi all squared, and that gives a value of 226.3536 centimeters squared. So to 3 significant figures, the final answer is 226. In the first part of question 7, we are told to factorize this quadratic expression. So simply put, we need 2 factors of -48 that add to give us 2. And those values are 8 and -6. So the final answer is x plus 8 multiplied by x minus 6. In the second part of this question, we are told, hence solve this quadratic equation. So given as we have already factorized the left side of this equation in the previous part of this question, we can set both of these brackets equal to 0, in which x will either equal -8 or x will equal 6. And those are your final answers. In the first part of question 8, we are told to write 5.76 times 10 to the 4 as an ordinary number. And if you put that into your calculator, you get 57,600 as your answer. In the second part of this question, we are told to work out this fraction and to give our answer in standard form. So before we put this fraction into our calculator, we need to use BIDMAS. So remember that multiplication comes before addition, so we need to put brackets here and brackets here. And when you put that into your calculator, you get 308,000 divided by 0.04, and that gives us a value of 7,700,000. And in standard form, that's the same as 7.7 times 10 to the power of 6. In question 9, we are told that Mark has 3 bags, bag A, bag B, and bag C. Bag A contains 120 counters. The probability of taking at random a red counter from bag A is 0.45. Bag B contains 80 counters, and the probability of taking at random a red counter from bag B is 0.3. Bag C is empty. Mark puts all the counters from bag A and bag B into bag C. Mark takes at random a counter from bag C. Work out the probability that he takes a red counter. So the probability that Mark takes a red counter from bag A is 0.45 multiplied by 120, and that gives us a value of 54. And the probability that Mark takes a red counter from bag B is 0.3 multiplied by 80, and that gives us a value of 24. And given as Mark puts all the counters from bag A and bag B into bag C, the total number of red counters in bag C can be determined by adding 120 and 80, and that gives us a value of 200. So the probability of Mark taking a red counter from bag C can simply be determined by adding the probability of him taking a red counter from bag A and from bag B, which will be a total of 54 and 24, and dividing that by the total number of red counters in bag C, which is now 200. And when you put that into your calculator, you get a final answer of 39 over 100. In the first part of question 10, we are told that on the number line represents the inequality W is less than 1. So the first thing we need to do is draw a circle over the number 1, and this has to be an open circle because W is less than 1 and not less than and equal to 1. and given as w is less than 1, we need to draw an arrow to the left which represents all the possible integers and values that w can be, and that is your final answer. In the second part of this question, we are told that the region R shown shaded in the diagram is bounded by 3 straight lines. Write down the 3 inequalities that define the region R. So the first thing we need to do is we need to write the equations of all the straight lines. So we're going to start with the first horizontal line at the top, and that is simply the equation y equals 4. On our diagonal that goes through the origin is y equals x, and the vertical line on the left is x equals -3. So given as the shaded region is below the line y equals 4, we can state that the equation of that inequality is y is less than or equal to 4. And one thing to note is that all of the inequalities will be inclusive because we have solid lines. The second inequality we have for the line y equals x will simply be y is greater than or equal to x, because if we plot a random point, for example the point 1, 2, and we substitute that into the equation y equals x, we have 2 equals 1, and given as this is not true, 2 can only be greater than or equal to 1. And finally, for the equation x equals -3, given as the shaded region is to the right, we can simply state that x has to be greater than or equal to -3. And those are your final answers. In question 11, we are given a right-angled triangle ABC. The area of triangle ABC is 240 centimeters squared. Work out the perimeter of triangle ABC. So given as we have the area of this right-angled triangle, we can state that the base multiplied by the height divided by 2 equals 240 centimeters squared. So the base, which is 30, multiplied by your height AC divided by 2 equals 240 centimeters squared. So the length AC can be determined by multiplying 240 and 2 and dividing that answer by 30, and that gives us a value of 16 centimeters. And in order to determine the perimeter of this triangle, we also need the length CB. And CB can be obtained using Pythagoras' theorem. So CB equals 30 squared plus 16 squared, and that equals 34 centimeters. So the perimeter of our triangle is simply the sum of 30, 16, and 34. And when you put all of that into your calculator, you get a final answer of 80 centimeters. In the first part of question 12, we are told to complete the table of values for y equals a half multiplied by x plus 4 over x. So all you simply need to do is substitute your value of x equals 1 into this equation of y, and that gives you a value of 2.5. And the same can be said for x equals 2, and that gives you a y value of 2. In the second part of this question, we are told to draw the graph of y equals a half multiplied by x plus 4 over x, for which x is greater than or equal to 0.5 and less than and equal to 6. So the first thing we need to do is plot the x and y values from our table of values onto this graph. And given as there are 10 boxes between 0 and 1, each box represents 0.1. So the first value will be roughly here. The second value will be at 1, 2.5, which is there, and I'll plot the point 2, 2, and then you can repeat the same for all the other values in your table. And the final step is to connect all these points. And that is the final answer. In the final part of this question, we are told that by drawing a suitable line on the grid, find estimates for the solutions of the equation x plus 4 over x equals 6. So the first thing I'm going to do is state that the equation y equals a half times x plus 4 over x, because that's the equation of the graph we drew in the previous part. And given as x plus 4 over x equals 6, I can state that y equals a half multiplied by 6, and that equals 3. So what we need to do is draw the equation of the line y equals 3 and determine the values of x at the points of intersection with the curve y equals a half times x plus 4 over x. So the equation of the line y equals 3 is a horizontal line that looks like this, and my values of x are simply at the points of intersection, and the values of x are simply at the points of intersection. So that's roughly 0.75-ish or 0.7, and this is roughly 5.2. So the final values are x equals 0.7 and x equals 5.2. In the first part of question 13, we are told to simplify fully this expression. So using the law of indices, I can simply write this as 125 to the power of 2 over 3 multiplied by x to the power of 6 all raised to the power of 2 over 3 divided by y to the power of 15 all raised to the power of 2 over 3. And so 125 to the power of 2 over 3 is simply 25. and x to the power of 6 or raised to the power of 2 over 3 is the same as x to the power of 6 times 2 over 3, which is x to the power of 4, and y to the power of 15 or raised to the power of 2 over 3 is the same as y to the power of 15 times 2 over 3, and that gives you a value of y to the power of 10. So your final answer is 25x to the power of 4 divided by y to the power of 10. In the final part of this question, we are told that given that 4 to the power of n equals 4 to the power of m over 64 to the power of p, express n in terms of m and p. So using the law of indices, we can simply write 64 as 4 cubed, and I'll raise all of that to the power of p. So the right hand side of this equation can simply be written as 4 to the power of m divided by 4 to the power of 3p, because remember, when you have an indices raised to another power, you can multiply these two values. And also remember that whenever you divide two indices with the same base, you can subtract their powers. So this is the same as 4 to the power of n, and that equals 4 to the power of m minus 3p. Therefore, n simply equals m minus 3p. In question 14, we are told that the cumulative frequency graph shows information about the heights of 40 plants that Greta has grown. In the first part of this question, we are told to use the graph to find an estimate for the median height. So the median is halfway between 0 and 40, which is 20, and we need to draw a straight horizontal line to where it meets the curve, and then draw a vertical line to where it meets the x-axis, and that will roughly be 27 centimeters. In the second part of this question, we are told to use the graph to find an estimate for the interquartile range of the heights. So the interquartile range can be determined by subtracting the lower quartile from the upper quartile. So the upper quartile is halfway between our median and our maximum value, so that's going to be 30. So we'll draw horizontal lines where it meets the curve, and then draw a vertical line going down, and that value is 35. And the lower quartile is halfway between our minimum value and the median, so that's going to be 10. And we'll draw straight horizontal lines where it meets the curve, and then the vertical line going down, and that value is 19. So the interquartile range is simply 35 minus 19, and that value gives you 16. And that is your final answer. In the final part of this question, we are told that plants with a height greater than 40 centimeters are premium plants. In the final part of this question, we are told that plants with a height greater than 40 centimeters are premium plants. Greta sells all the premium plants for €30 each. Work out the total amount of money Greta receives for the premium plants. So the first thing we need to do is determine the number of plants that have a height greater than 40 centimeters, and that can simply be determined by drawing a straight vertical line from the point 40 on our x-axis to the curve, and then we'll draw a horizontal line to the y-axis, and that value can simply be seen as 34. So the total number of plants greater than 40 centimeters is 40 minus 34, which is 6. And given as Greta sells all the premium plants for €30 each, we need to multiply 6 by 30, and that gives us a value of 180. So the final answer is €180. In question 15, we are told that A, B, C, and D are points on a circle with center O. Angle DAB equals 48 degrees. Work out the size of the obtuse angle DOB. So the obtuse angle DOB is this angle here, and very clearly we can see that this angle is going to be double the angle DAB, because the angle at the center is twice the angle at the circumference. In part B, we are told to work out the size of angle BCD and to give a reason for your answer. Angle BCD is this angle right here, and given as we have a cyclic quadrilateral, this angle can be obtained by subtracting 48 from 180 degrees, which is 132 degrees. And the reason for this is because opposite angles in a cyclic quadrilateral add up to 180 degrees. And these are your final answers. In question 16, we are told to use algebra to show that 0.37 recurrent 8 recurrent equals 25 over 66. So the first thing we need to do is state that x equals 0.378 recurrent, and the next step is to multiply both sides by 100, and that gives us this. And now that we have these two equations, I'm going to call this equation 1, and I'm going to call this equation 2, and I'm going to subtract equation 1 from equation 2. So I have 99x, and that will equal 37.5. So x can simply equal 37.5 divided by 99. And remember, we already stated that x is 0.37 recurrent 8 recurrent, so that's just the same as 37.5 over 99. and I can multiply the numerator and the denominator by 10, so 375 divided by 99, and when you put that into your calculator, that simply gives you 25 over 66, and that is your final answer. In question 17, we are told that t is inversely proportional to the square root of m. T equals 15 when m equals 36. Find a formula for t in terms of m. So given as t is inversely proportional to the square root of m, we can state that t is proportional to 1 over root m. And in order to get rid of the proportional symbol, we need to include an equal sign and a constant, which I'll call k, and we'll multiply that by the square root of m. And using the values of t and m, we can determine the value for k. So 15 equals k times 1 over the square root of 36. So 15 equals k times 1 over 6. Therefore, k equals 15 multiplied by 6, and that value is 90. And now that we have the value of k, we can substitute this into the equation for t. So t equals 90 times 1 over root m. In question 18, we are told that Bianca asked 40 students which of the languages, Latin, Greek, and Sanskrit they study. The Venn diagram gives some information about her results. It shows the number of students in each subset. One of these students is selected at random. Work out the probability that this student studies Latin or Sanskrit. So the first thing we need to do is determine the value of x, and that can be evaluated by summing all the values in our Venn diagram and setting that equal to 40. And when we simplify the left side of this equation, we have 26 plus 7x, and that equals 40. So 7x equals 40 minus 26, which is 14. Therefore, x equals 2. So the probability of this student studying Latin or Sanskrit can be determined by adding all the values in the Latin circle and all the values in the Sanskrit circle. So 5 plus x plus 2x plus 4x, which is 6x, will be divided by 40. And if we simplify that, we have 5 plus 7x all over 40. And given as x equals 2, we have 5 plus 7 times 2 divided by 40. And that simplifies to 19 over 40. And that is the final answer. In question 19, we are given two functions f and g, and in the first part of this question, we are told to find the function g of x at which x equals 3. So when we substitute x as 3 into a function of g of x, we have 3 divided by 2 times 3 minus 1, and that gives us 3 over 5. In the final part of this question, we are told to find g f of x and to give our answer in its simplest form. So g f of x can be determined by substituting the function of x as x into the function of g. So where I have x in the function of g of x, I'm going to replace with 3x minus 2. So I have 3x minus 2 divided by 2 times 3x minus 2 minus 1. And that simplifies to 3x minus 2 over 6x minus 4 minus 1. And so the final answer is 3x minus 2 all over 6x minus 5. In question 20, we are given a quadratic equation. The solutions of this equation are given by x equals minus 4 plus or minus 2 root 39 over 10. Find the value of a and the value of c. So if we use the quadratic equation, which is provided in the formula book, we can clearly see that 2a can be set equal to 10. And so a equals 10 divided by 2, which is 5. We can also state that minus b equals minus 4, so b equals 4. And for the second term in our numerator, which is the square root of b squared minus 4ac, we can set this equal to 2 root 39 and solve for c. So if we square both sides, we have b squared minus 4ac, and that equals 156. And when we substitute our values for a and b, we have 4 squared minus 4 times 5 times c, and that equals 156. So 16 minus 20c equals 156. Therefore, 20c equals 16 minus 156, and that equals minus 140. So the value of c equals minus 140 divided by 20, and c equals minus 7. And these are your final values. In question 21, we are told that the histogram shows information about the times in minutes that some trains arrive late at a station one day. 20 of these trains arrived between 10 minutes late and 15 minutes late. No trains arrived more than 60 minutes late. Work out an estimate for the number of these trains that arrived at least 25 minutes late. So the first thing we need to identify is that the frequency equals the frequency density times the class width. And using the first bit of information, we can state that 20 equals the frequency density multiplied by 5. So the frequency density equals 20 divided by 5, which is 4. and I'm going to label that on our histogram. And using this information, I can label the rest of this histogram. And given as we need to work out an estimate for the number of these trains that arrived at least 25 minutes late, I need to draw a vertical line down to the point 25 on the x-axis, and the frequency, which is a number of trains, can be determined by obtaining the value of the area of each of these bar charts. So the area of the first bar chart can be determined by multiplying the frequency density, which is 3, by the class width, which is 5, and that gives us a value of 15. The second area can be obtained by multiplying the value of 1 by 10, and that gives us a value of 10. And the final area can be determined by multiplying the frequency, which is 0.7, by the class width, which is 60 minus 40, and that is 20. And that gives us a value of 14. And in order to obtain the estimate, we need to add all these values together. So we have 15 plus 10 plus 14, and when you put that into your calculator, you get a value of 39. In question 22, we are told that a curve C has equation y equals x cubed minus 16x plus 7. At 2 points on C, the gradient is 11. The tangents to C at these 2 points have equations of the form y equals ax plus b. Work out the 2 possible values of b. So seeing as the gradient is 11, we can set the gradient function equal to 11. So dy by dx simply equals 3x squared minus 16, and we can set that equal to 11. So 3x squared equals 11 plus 16, which is 27, and x squared equals 27 divided by 3, which is 9. So x equals plus or minus 3. So in order to determine their corresponding y values, we need to substitute these values of x into the equation of our curve C. And so when x equals 3, y equals minus 14. And when x equals minus 3, y equals 28. And in order to determine the value of b, we can substitute these coordinates into the equation of our straight line y equals ax plus b. So for the first point, 3 minus 14, we have the equation y equals 11x plus b, and if we substitute x as 3 and y as negative 14, b equals minus 14 minus 33, therefore b is minus 47. And for the second point, minus 3, 28, we can substitute these into the same line equation, giving us this. So b equals 28 plus 33, therefore b equals 61. And these are your final values. In question 23, we are told that shape P is similar to shape Q. The table shows some information about shape P and shape Q. Work out the volume of shape Q. So the scale factor can be written as L squared in relation to the surface area, and we can obtain this value by dividing 450 by 200. So the scale factor in relation to the volume, which is L cubed, can simply be obtained by taking the square root of 450 over 200 and then cubing this value, and that simply gives us a value of 27 over 8. So the volume of Q can be obtained by multiplying 672 by 27 over 8, giving us 2,268 centimeter cubed. In question 24, we are given an equation d equals n over p minus q and the following information, and by considering bounds, we have been asked to work out the value of d to a suitable degree of accuracy. So given as n has been rounded correct to 1 decimal place, we can divide 0.1 by 2, and that gives us a value of 0.05, and p and q have both been rounded correct to 2 decimal places, so we can divide 0.01 by 2, and that gives us a value of 0.005. And this is what we are going to add and subtract to each of these values to determine our upper and our lower bounds. So the upper bound of d can be determined by dividing the upper bound of n by the difference between the lower bound of p and the upper bound of q. And the lower bound of d can be determined by dividing the lower bound of n by the difference between the upper bound of p and the lower bound of q. And in case any of you were wondering how we know this, remember that if you want your value to be as big as possible, your numerator needs to be as high as possible and your denominator needs to be as small as possible. And if you want your value to be as small as possible, your numerator needs to be as small as possible and your denominator needs to be as large as possible. And in order to determine the upper and lower bounds of n, p and q, we need to add and subtract these values to their original values. So for n, I'm going to add 0.05 to 10.3 and that'll give me 10.35, and I'll subtract 0.05 from 10.3 and that gives me 10.25. And I can repeat the same for p and q. Therefore, to determine the upper and lower bounds of d, I can substitute all of these values into my equations. So the upper bound of d is this, and the lower bound for d is this. So the upper bound of d correct to 1 decimal place is 3.6. and the lower bound of d correct to 1 decimal place is also 3.6. So the final value is 3.6. In question 25, we are told that the first term of an arithmetic series is 10, the 20th term of the series is 86, the sum of the first n terms of the series is 5194, work out the value of n. So given as the first term of the arithmetic series is 10, we can simply state that the value of a equals 10, and the nth term of a linear sequence can be written as this. So our first term, which is 10, plus 20 minus 1, which is 19, multiplied by d equals 86. So 19d equals 86 minus 10, which is 76. Therefore, d equals 4. And given as we are told that the sum of the first n terms of the series is 5194, we can set this equation equal to 5194 and solve for n. So n over 2 multiplied by 2 times a, which is 20, plus n minus 1 multiplied by d, which is 4, all equals 5194. And if I multiply both sides by 2 and simplify the brackets, I have this equation, and the next step is to expand the left-hand side and set this entire equation equal to 0. And to make this quadratic equation easier to solve, I'm going to divide the entire equation through by 4 to get this. And finally, I can factorize this quadratic equation to determine my final values for n. So we have n plus 53 multiplied by n minus 49, and that equals 0. So my final values for n are minus 53 and 49. And given as n cannot be less than 0, the final value for n is 49. In the final question for today's video, we are told that a solid cone is joined to a solid hemisphere to make the solid shown below. The cone is made from copper. The density of the copper is 9 grams per centimeter cubed. The hemisphere is made from a different metal. The total mass of the solid is 4,752 pi grams. The total volume of the solid is 504 pi centimeter cubed. Work out the density of the hemisphere. We can state that the volume of the cone plus the volume of the hemisphere equals 504 pi, and the volume of a cone and the volume of a sphere can be determined using these equations. So the volume of the solid cone is a third multiplied by pi multiplied by the radius, which is x squared, multiplied by the height 5x, and that simplifies to 5 over 3 pi x cubed. And given as we have a solid hemisphere, we need to divide the volume of the sphere by 2, and that gives us 2 over 3 pi x cubed. And if we substitute these expressions into the equation of our volume, we get this, and when we simplify the left-hand side, we have 7 over 3 pi x cubed, and that equals 504 pi, so x cubed equals 216. Therefore, x equals the cube root of 216, and that value is 6. And given as the total mass of the solid is 4,752 pi grams, we can simply state that the mass of the cone plus the mass of the hemisphere equals 4,752 pi. And given as density equals mass over volume, the mass can be obtained by multiplying the density by the volume. So the mass of the cone is equal to the product of the density of the cone and the volume of the cone. And given as the cone is made from copper and the density of copper is 9 grams per centimeter cubed, we can state that the mass of the cone equals 9 multiplied by the volume of the cone, which is 5 over 3 multiplied by pi multiplied by x cubed, which is 216, and that equals 3,240 pi grams. And so the mass of the hemisphere can be obtained by subtracting the mass of the cone from the mass of the solid, giving us 1,512 pi grams. So the density of the hemisphere can be obtained by dividing the mass of the hemisphere by the volume of the hemisphere. And when we put that into our calculator, we have 21 over 2 grams per centimeter cubed. And that is the final answer. Thank you all for watching today's video. I hope this walkthrough has helped boost your confidence for upcoming exams. If you found this video helpful, don't forget to give it a thumbs up as it really supports the channel. And if you're new here, don't forget to subscribe to S.E.T for you for more walkthroughs, engineering insights and STEM inspiration. If you have a question or topic you'd like me to cover, don't forget to drop it in the comments. And until next time, keep practicing, stay curious, and I'll see you all in the next video.